So at the last minute, Carol couldn't be here, so she sends her sincere regrets for not being here, and I share my sincere regrets that you have to listen to me again, especially so soon. So I had nothing to do with this research, but here are the authors up here. It was a collaboration between many different individuals and groups focused on strikers. So in the last 5 years or so in the UK, there have been 7 tidal projects commissioned in UK waters. Unfortunately, the projects that have moved forward haven't, in terms of post-consent monitoring, haven't provided us much in the way of insights into collision risks, either because the devices that were being run were required to shut down when a marine mammal was nearby, or there was no dedicated, or there hasn't been no dedicated near-field monitoring to try to understand these interactions with marine mammals. One of the points that Carol wanted me to make on this slide was that much has been made about the number of operating hours that have been achieved by a lot of these devices, but that lack of evidence of impact is not the same thing as evidence of lack of impact. So what she wanted this talk to focus on were these 2 projects, the SeaGen in Strangford and the DeltaStream Tidal Energy Limited in Ramsey Sound. So I think everybody's familiar with the SeaGen project. It was installed in 2008. It is in a European special area of conservation, with harbor seal population being the qualifying feature. And because of that, the special importance of the seal population and the uncertainty surrounding collision risk, shutdown mitigation was put in place. So in the early days, it was MMOs standing on the structure with ready to shut the system down when marine mammals got close. And then that was converted eventually to active sonar, and that mitigation continues to this day. But as long as the mitigation is in place, we're not taking advantage of an opportunity to learn about the close range interactions between marine mammals and tidal turbines. And so SMER Marine, Royal Haskoning, MCT worked together with the Strangford Science Group and the Northern Irish Regulator, right here, DOE, over the past 18 months to license a trial removal shutdown for mitigation. And this has been through an adaptive management process. And Carol wanted me to encourage you to go see Beth Mackey's poster on the adaptive management process. Unfortunately, this project I think Carol was hoping to present some preliminary results to you at this point, but there have been delays, but they're hoping that they'll transition to this study this summer at Strangford. So she wanted me to give you an overview of where this project and the project in Ramsey Sound are going. So in terms of the process of how this happened, so the first step has been the conclusion of the EMP, showing that there were no significant impacts on marine mammals in terms of barrier effects, no significant disturbance, and no changes in abundance. And that's all documented in this report that was completed in January of 2012 and is available online. The second step is conducting this risk, reassess the risk of assessment after 5 years of operational data. And then the third is to carry out a habitat regulations assessment. So this step 2, what is the close range encounter between seals and turbines? And there were 3 data sources that they used to try to assess this. One was the Seaking sonar, which is a mechanical scanning sonar, and then some multi-beam sonar work that Gordon did in the summer of 2011, and then some seal telemetry data on 12 harbor seals that were tagged in 2010. So in terms of the Seaking, its primary purpose was for mitigation and shutdown of the turbine when seals were around. But the nice thing about it is that it gives several years of data that cover all times of the year. And I think that's pretty crucial in terms of estimating the variation in terms of the number of seals that might come near turbine blades. And then, as I mentioned, this is Gordon's work that was done in May through July of 2011 using the Tritech Gemini sonar. And I guess the one thing I would point out here is that you've got a nice broad angle looking out to the from the MCT turbine. But the picture that you're getting over here is tells you nothing about the depth that the seals are at, right? Because it's actually imaging the whole water column. And that's important, and that's why, or I guess I should also point out that Gordon's report is also available at that URL. You can get it from me later if you want. And I think the reason why I brought up the depth on the previous slide is that that was one of the missing pieces that was needed, and that's what the SMRU seal tags managed to do, was to provide depth estimates in closed during these close transits of 12 tagged seals. And this is the depth data that came out of that. So this blue sphere is basically the swept area of the rotors for the turbine, and on the x-axis is the percent usage, and on the y-axis is the depth. And what it clearly shows is that these seals seem to be diving either more shallow than the rotor swept area, or all the way to the bottom, or deeper, I should say. So, in terms of their actual encounter rate estimates, I think there are some circles in here that Carol wanted me to highlight. And in terms of, so you have the different data sets on the top here. On the left here, you have the different estimates based on whether you would estimate, if you didn't have depth information, you would just estimate uniform depth. And you'll see that the estimates, if you went from, say, let's just use this particular sonar, it's a significant decrease from just assuming a uniform depth to actually using the depth that were measured from those tags. The other thing she wanted me to point out on here is that there is quite a large seasonal variation, and that's what was nice about the Seaking sonar, was that they could start to get at that seasonal variation. And the other thing she wanted me to point out is that across sensors, so this Seaking, the Gemini Multibeam sonar, and then also the seal tags, all give us very similar estimates, which is reassuring. The numbers over here in terms of avoidance at uniform or non-uniform depth, the reality is that there is no information yet in terms of avoidance. I'm told, at least, that 95% avoidance is sometimes used for birds and wind turbines. I think that for their modeling, they decided to settle on the 50% avoidance. But at least that gives you some sense of, when you vary those factors, how much that changes things. So in terms of, well, I better look at my notes. I'm going completely off notes. In terms of the models that were implemented, they tried out a simple model that was based on fish passing through hydroelectric power stations. This is the work that I think Mike Lonergan did. And then they also used a modified band model that's been used by Marine Scotland. There's no way I could go into the details of the model because I wasn't involved in it, but I'm sure that Carol will be happy to explain those to anybody who wants to know those. In essence, the numbers down here are the probabilities under these different models and animal movement assumptions. And so the movement assumptions are right here. This is passive, meaning they're just drifting with the currents. And this is with the animals moving at 2.3 meters per second, I believe. Let's see. So in essence, this would suggest a probability of a quarter, right, for interaction, I think, between the animals and the turbines. So you take those numbers from that model, and assuming a non-uniform depth distribution of 50% avoidance, you can come up with this estimated collision risk of roughly 1 seal per month in the summer and a 0.3 seals per month in the winter. And based on that information and this information in terms of the population, so these are population estimates over time, and you can see there's a bit of an increase of recently. And so based on the PBR estimates of 3.6 seals per year and your estimate of 1 seal potentially interacting with the turbine per month in the summer months, that gives you the final determination that you could do this trial for 3.5 months without exceeding your PBR on this population. And so I think that was the rationale that was used for licensing this trial for this summer for 3.5 months. Does that make sense? I hope so. Anyway, so the trial that's moving forward in Strangford is going to have this set up with four Gemini Multibeam sonars. They'll be mounted near the structure, facing out. The reason to use 4 is to try to cover as much of the swept area, the rotor swept area, as possible. So this is the side view. This is the plan view looking down. So it should cover both forward and aft of the rotating turbines. And they're hoping to use this data to refine the collision risk estimates based on this new data, and then hopefully directly record any evasion or avoidance behavior around the actual rotors. So she says, watch this space since this will happen this summer. Okay, and then I think sort of to start wrapping this up in terms of the second project, the Tidal Energy Limited's DeltaStream project in Ramsey Sound. Similarly, monitoring is being planned around this device that they're hoping to be installed this summer. It's also an SAC it's designated for gray seals, and there's also large numbers of harbor porpoises. So there's similar uncertainties about collision risks. And so they're trying to measure fine-scale interactions of marine mammals around these turbines, again, to understand collision risk. And that'll happen this summer. Some of the ways in which they hope to achieve that is using a passive acoustic system. It's a little bit hard to see here, but each of these yellow dots, so there are 4 yellow dots on the base of the structure itself. Each of those yellow dots will have a cluster of 3 hydrophones. And this is, Jamie can answer some of these questions if you've got these later, but these will be used to localize harbor porpoise that are coming near the turbine. So similar to his system that he was talking about just earlier, but except it's not a drifting system, it's actually mounted onto the structure itself. And then this is the active acoustic monitoring, and slight variant on what we've seen in, say, for example, Brian Pelagi's AMP and the flowback package. This will be actually cabled onto a separate platform that's some distance that I forget. I think it's 30 meters or so off to the side, and then face so this is the swept area of the multi-beam around the actual structure. And this purple area is going to be the area that the Tritech software is going to be looking for motion detection to try to trigger a warning of an animal coming closer to the site. So that's the plan view, and this is the side view showing that based on the distance away and the angle that the aperture of that particular sonar, that they should be able to cover the rotor swept area. And I will leave it at, those are Carol's contact information. I have her cards here, so I'm happy to just hand you her card as well, and she'd be happy to answer any questions for you.